Okay, so hi, Assalamualaikum. So this is presentation video for our group project, and my name is Mak Faisifah bin Jamaluddin, and here is my teammate.
Okay. Hi, my name is Muhammad Zain Faris.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Risa Kalbi Mazlan, and I'm going to be presenting my part in my project. Now I'm going to start presenting on the introduction. As university student ourselves, we experience firsthand how dense lecture schedules, heavy assignment workloads, and exam preparation force us to compromise our health. This section outlines our focus on daily variables, specifically sleep hygiene, physical activity, study patterns, and screen time, to uncover how these habits interact and impact general student well-being. First, we implemented a two-sample hypothesis test to see if the sleep duration differs by gender. Second, we used correlation and simple linear regression to analyze how study hours affect self-rated sleep quality. And third, we employ a chi-square test of independence to examine caffeine consumption habits.
Okay, so for our data set, we use global data set on student sleep patterns and lifestyles, with a population of university students worldwide and a sample size of 500 students. The dataset contains 14 variables in total. These include both quantitative, qualitative, variable across different measurement levels: nominal, ordinal, ratio, interval, and interval. Some key variables we focus on are: okay, so for gender, the type of variable is qualitative, measurement level nominal, sleep duration, quantitative and ratio, study hours, quantitative and ratio, caffeine intake, quantitative and ratio, and yeah. Moving on to statistical test analysis, we selected 4 pairs of variables for testing. First, gender and sleep duration. Second, study hours and sleep quality. Third, study hours and sleep quality. And the last one is gender and caffeine intake. So for the first one, where we applied 2 sample t-test to determine whether average sleep duration differs between male and female students. So for the second one is between study hours and sleep quality, where we used correlation analysis to examine relationship between study hours and sleep quality among students. And for the third one, is between study hours and sleep quality to analyze the correlation analysis to examine the relationship between study hours and sleep quality among students. And the last one is gender and caffeine intake, where we apply a chi-square test of independence to determine whether caffeine intake levels differ across genders. Okay, so move to the next checkpoint.
Now, for session 3.1, we conduct a two-sample t-test to determine whether there is significant difference in average sleep duration between male and female students. Okay. The two variables used are gender as independent variable and sleep duration as the dependent variable. And then from the data set, we obtain the following descriptive statistic for female student. The sample is 166 with a mean duration of 6.5 hours and a standard of deviation of 1.5. Okay. For male student, the sample size is 186 with a mean sleep duration of 6.4 hours and a standard deviation of 1.5. And then using the RStudio code, we perform the wedge two sample t-test at a 95% confidence level, assuming an equal variance from the output. The test statistic obtained was T null 1.0899 with a degree of freedom equal to 344.67 and a p-value of 0.2765. The 95 confidence interval for the difference in means from negative 0.39808870 and to 0.48763134. This means we are 95% confident that true difference in mean sleep duration between female and male student lies within this range. Since the p-value of 0.2765 is greater than our significant level A, that's equal to 0.05, and the test statistic equal to 1.0899 falls between the critical value, which is uh, which is the critical value negative 1.9669 and 1.9669, and we we fail to reject the null hypothesis. Therefore, there is insufficient evidence to conclude that the mean sleep duration of the female student is different from the mean sleep duration of male student at A equal to 0.05. Uh, and then from the article, I'm doing this data visual using box plot. As you can see in the box plot, both groups have similar medium sleep duration, which support our conclusion. Okay, moving to section 3.2, we doing a correlation analysis to determine whether there is a linear relationship between study hour and sleep quality among students. The two variables used are study hour and the independent variable sleep, and the quality as the dependent variable. Looking at the scatter plot, we can observe that data points are widely scattered with nearly flat regression line, suggesting a very weak relation between two variables. Using RStudio, we can determine whether the relationship is statistically significant. Method uh, to calculate the recent correlation coefficient, uh, uh, and that's R equal to 0.0587. This value indicated a very weak positive linear correlation between study hour and sleep quality. And then for a significant test, the null hypothesis state there is no linear correlation between study hour and sleep quality, and the alternative hypothesis state the linear correlation exists. Using the formula, we calculate the test statistic t equal to 1.312378 at significantly A level with degree of freedom 498, and the critical value are negative 1.4739 and 1.94739. So we can conclude that there is an insufficient evidence to conclude that there is a linear relationship between study hour and sleep quality among students at A equal to 0.05. And you can see here the performing significant test for correlation using RStudio Code.
Next, I'm going to present about regression analysis. We look at our simple linear regression model, building our correlation analysis. We wanted to see if a student's daily workload could actively predict our sleep quality. For this model, our independent variable x is defined as average daily study hours, while our independent variable y is self-rated sleep quality measured on a scale of 1 to 10. Look closely at the calculated model equation right there in y equals 5.3852 plus 0.0241x. Our slope coefficient B1 is 0.0241. This mathematically implies that for every additional hour of student studies per day, their sleep quality is expected to increase by just 0.0241 unit. This incredibly small value give us an early indication that the regression line is practically flat, means changes in study hours have almost no visible impact on sleep quality ratings. To verify if this relationship holds any real weight, we set up a formal hypothesis test on the slope at 95% confidence level. Our null hypothesis, H0, states that the true slope is 0, meaning study hours have no linear effect on sleep qualities. Looking at our RStudio calculation, results stated here in the report, we obtained the t statistic of 1.3142 and 498 degrees of freedom, and the p-value of 0.190. Additionally, our coefficient of determination, the r-squared value, is just 0.00345. This critical value tells us that a mere 0.35% of the variance in student sleep quality can actually be explained by the daily study hours. The remaining 99.65% is influenced by other factors. With our critical value threshold at 1.9647 for a two-tailed test, our calculated t-value is at 1.3124, falls completely within a non-rejection region. Furthermore, our p-value of 0.190 is significantly higher than our alpha level 0.05. Therefore, as concluded at the bottom of the section, we fail to reject the null hypothesis. There is insufficient evidence to state that the daily Study hours are statistically significant predictors of sleep quality. Academy workload alone isn't defining factors of sleep health, directing our attention toward our lifestyle variables and for future exploration.
Okay, now I will walk through our chi-square test of independence using the variable gender and caffeine intake. We first group the caffeine intake into three categories: low, 0 until 1, medium, 2 until 3, and high, 4 until 5. And male, female, others, and others. So we state our hypothesis. So the H null is both of variables are independent, and H alternative is both variables are dependent. And find the critical value. So critical value here is using using 0.05 and 4 is not, we got 9.488. By using the R Studio, the value is 0.4877, like this picture state here. And then we move on to calculate the expected count. So we then calculate the expected count for each cell and computed the chi-square test statistic using the formula summing observed minus expected squared divide by expected across all cells. Our manual calculation gave us a test statistic of 0.4706, which was also confirmed by R Studio. R Studio also returned a p-value which is 0.113730. So since our test statistic is 7.4706 is less than critical value of 9.488, it does not fall within the critical region, and since our p value is 0.1130 is greater than 0.05, we fail to reject the null hypothesis. So the conclusion is therefore there is insufficient evidence to conclude that there is a significant association between gender and intake among students at 0.05. In other words, our students does not significantly influence how much they consume. So that's all for 3.4.
Okay, for the last one is the conclusion for our project. In conclusion, this project has given us a valuable experience in both statistical analysis and R programming. Through the project, we learned the importance of selecting a suitable dataset that meets the required dimension for analysis. We also gain a better understanding of how to use RStudio to perform calculation, generate outputs, and interpret the result accurately. And we also working with R help us improve our coding and data analysis skill by writing and running different statically tests. And we learn how R can simplify complex calculation and help us make a data-driven conclusion. This experience will be useful for the future project involving data analysis and research. Based on our finding, the two sample hypothesis tests show that there is no significant difference in sleep duration between male and female students. The correlation and regression analysis indicate a very weak positive relation between study hour and sleep quality, meaning that study hours are not significant predictive of sleep quality. And furthermore, the chi-square test revealed that gender and caffeine intake level are independent of each other. Overall of our project, the results suggest that sleep pattern among university students are not strongly influenced by gender or our study hour alone. Other factors may have greater impact on sleep quality and should be explored in the future studies. And that's all for our projects. Thank you.